Hi, hi everyone. Welcome to my YouTube channel. I'm Vinay BK, Assistant Professor in the College of Channabasaveshwara Institute of Technology, short CIT, Gubbi Tumkur, 87. So I am from Electrical and Electronics Department. Uh, so here I wanted to share few things. That is, I wanted to share my views on model question paper that they uploaded in a video website. So that I'm here to discuss about subject called basic electrical engineering. And in this subject, I can go to the video website. We will be having two model question paper set. So in that, I'll take one question paper set, that is a model question paper set one. Okay. So what you can learn from this video is that so I'll just tell you that how we can write an examination for the question which carries around 6 marks, 8 marks, if it is a 10 marks. Okay, so that in this subject you can see, so you'll be having 5 modules, 10 questions. In that 10 questions, you have to write full 5 questions, and one compulsory question from each module is having 20 marks. Okay, so now without wasting time, let's go for the question paper set 1. Model question per set 1. In that module 1 questions is just observed here. So in this first question is illustrate with examples Kirchhoff's law as applied to an electric circuit. So most of the students, what you guys can do that. So you just write the statements. You're not going to explain anything in the what KCL or else KVL. So they will lose the marks. They will lose the marks. So what you guys can do means that you have to write the statement and you have to give some example. You have to explain that along with the sign conversion. So because it will be having what 8 marks. So let us see now the first question. First, you write the statements of both the two laws, that is Kirchhoff's current law as well as Kirchhoff's voltage law. We all know that Kirchhoff's current law states that the algebraic sum of all the currents meeting at any junction of an electric circuit is zero. That is nothing but a summation of current I equals to zero. Explanation, what you have to write? You have to write the explanation of sign convention, so that I will take 5 branches. So I'm giving some direction of the current. I1 is downward, I2 is leaving the junction, I3 is leaving the junction, I4 is entering the junction, and I5 is also entering the junction. So I have to write the sign convention. If the current is entering positive, current is leaving the junction negative. So based on that, you can write one more definition, that is at any junction of electric circuits, the sum of all the currents entering the junction will be equal to the sum of all the currents leaving from the junction. Okay. Then what I have to write in KVL? Statement, sign convention, one simple circuit, and you have to explain that circuit. So what is the statement? In any closed electrical circuit, the algebraic sum of all the EMFs and resistive drops equals to zero. EMF is nothing but voltage. So it will be having the what polarity for EMF, polarity for resistive drops. You should know one thing, that the current which always flows through the supply from lower potential to higher potential. For example, if there is a battery, if it is having a lower potential and higher potential, sorry, lower potential and higher potential like this, the current which always flows from lower potential to higher potential, that is nothing but negative to positive. Sir, what about in a register? So if you are considering the register, so in this case, the current which flows from higher potential to lower potential. In register, it is flowing from plus to minus. current is flowing from plus to minus. Remember this point. So that that you have to remember. So now once after knowing this, you have to explain the KVL. So that is having, so in this KVL you can see sum of all the currents. Then you write the polarities. Then you take one example. So I will consider one example. The circuit is consisting of two resistors are connected in series across resistor. And with the help of this, you can easily remember the steps to solve problems also. So that I will consider there is a battery across two resistors. So the steps to solve the KVL problems. First, so in a problem, if they are given the direction of current, that is fine. If they are not given the direction of the current, what you have to do? So you only have to give the direction of current. So how will give the direction of current? Based on the supply as a priority. So as I told, in case of supply, the current is flowing from lower potential to higher potential. And so that you can see now lower potential is minus, higher potential plus. If they are not given the direction of the current, you only give the direction of current by considering voltage supply source as a priority. So this is the direction of current. I am assuming that I is flowing through the R1, R2 and coming back to the supply. Okay. So next. So based on the direction of current, give the polarities. In resistor, current flows from higher potential to lower potential. So that I'm writing based on the direction, current is flowing from higher potential to lower potential. So first give the direction of the current. Second, mark the polarity. Third, give the loop direction. If they are only given, fine. If they are not given, you only give the loop direction, either in a clockwise direction or in a anti-clockwise direction. Okay. So now I am giving the direction in clockwise direction. So what we have to do based on the direction of the loop, mark the second polarity. So now I am marking the second polarity. See now loop direction is clockwise. Based on that, second polarity is plus. So here the second polarity is minus, and again here the second polarity is minus. So now I will apply what KVL statement to this circuit, that is nothing but algebraic sum of all the EMF and resistive drop equals to 0. So that you can see now algebraic sum of voltage plus V. So now drop, voltage drop is nothing but IR drop, so that minus I into R1 minus I into R2 equals to 0. So this is the equation. Till that you have to write the examination. This is for 8 marks, so that, so if you're still having confusions, you just remember in the sentences, write statement of KCL, sign convention, take an example and explain. Then statement of KVL, sign convention and take this simple example and explain it for 8 marks. Okay, I hope you understand this. So next we'll go for the second question. You can see maximum power transfer theorem. Second question is from, prove that the circuit efficiency during maximum power transfer from source to load is only 50%. So there are two derivations in maximum power transfer theorem. The first derivation is that you have to prove the statement. What is the statement? So the statement is internal resistance should be same as load resistance. In some of the textbooks they are giving it as the source resistance should be same as load resistance, that derivation. So for this particular derivation, you have to prove that efficiency is 50% is when the maximum power is transferring. So that I'll consider a circuit of maximum power transfer theorem. So there is a source voltage V, internal resistance R, load resistance RL. If R equals to RL, that will be the statement of maximum power transfer theorem. So now with the help of this, efficiency is nothing but the ratio of output power to input power. So that this derivation steps you should remember. Efficiency they asked, so that efficiency is given by the ratio of output power to the input power. So that we need to write what is output power from the circuit diagram and what is input power from the circuit diagram. Then you have to apply maximum power transfer theorem, that is R equals to RL. Then you'll get simplified efficiency as output power to input power. So that I will define IL first. that IL is given by V divided by R plus RL. So just by applying the Ohm's law, V equals to I into R, whereas you'll be having two resistors in series, R and RL, so that you can get V divided by R equivalent is nothing but R plus RL. So I'll give this as equation number A. This is your equation number A. So next, I want to define output power and input power to get the efficiency. So that I will define output power. You can see output side. This is output side on load side. So that output power is given by IL square into RL. So IL is nothing but V divided by R plus RL. I'm substituting the value of IL. You'll get PL equals to V divided by R plus RL whole square into RL. Clear? Next, we have to define what? Input power. So input power means what? Input side. You can see input side. V. Here, load side will be having load resistance, so that you are considering IL square by RL. But for the input side, it is having two resistors. So that how we'll write? Input resistor is given by V. Input power is just write in terms of total voltage into total current. So that input power is given by V into IL. So again, what is IL here? From equation A, the IL is V divided by R plus RL. So you can get V square divided by R plus RL. Next, what you are doing? You are applying the maximum power transfer theorem rule. What is the rule? Internal resistance is same as load resistance, that is R equals to RL. Then you substitute these to the equation 1 and 2, you get V divided by 2R whole square. That is nothing but you can get here V divided by 4RL square, 4RL square into R. So RL and RL will get cancelled. So you can get V divided by 4RL. Similarly here, what is R equals to RL? So that you can write V square divided by, directly you can get V square divided by, so here also square, V square divided by, you can get 2 into RL, RL plus RL. See now, V square divided by 4RL, V square divided by 2RL. Output power is V square by 4RL. Input power is V square by 2RL. Just substitute, you will get V square by 4RL divided by V square by 2RL. You will get 1 by 2 is nothing but 0.5. Always you have to write efficiency in terms of percentage. So that multiply that 0.5 into 100, you will get 50%, and that will be the proof. Okay. So now, what the steps you have to understand is that the steps are very simple. First, circuit diagram you have to write. Then you define IL. Then you define output power IL square into RL. Then you define input power V into IL. Then substitute the value of IL, that is V divided by R plus RL. Then you apply maximum power transfer theorem, that is R equals to RL. You'll get output power, input power, that is V square by 4RL, V square by 2RL. Substitute that to the efficiency equation, you'll get efficiency is 50%. I hope it's clear. Back to the third question, that's 1C. The equation for an alternating current voltage. They are given V equation, that is nothing but 0.04 sine 2000 t plus 60 degree volts, and determine the frequency, angular frequency, and instantaneous value of an voltage when t equals to 160 microseconds. Remember, they have given the value of voltage, that is nothing but instantaneous value of voltage they are given, that is 0.04 sine omega t plus 5. So whereas 60 degrees is the phase angle, that is not necessary. They are only given. Just write as it is. But you can see here, V equals to Vm sine 0.04 is nothing but what? Vm. Omega t. Omega is nothing but what? 2000 radian per second. So they are only given 2000 radian. So that one answer we got, angular frequency, that is 2000 radian per second. Next, what they ask frequency. So I'll use the angular frequency formula. Omega is given by 2 pi f. So that f equals to omega by 2 pi. So omega is 2000, 2 pi as it is. We'll get frequency as 318.309 hertz. And second case, omega, they are only given. So what they ask in third case, instantaneous value of voltage. So instantaneous value of voltage is given by Vm sin omega t, whereas Vm is 0.04, omega is 2000, t they are only given 160 microfarad, sorry 160 microseconds. Substitute will get the value of voltage, instantaneous value of voltage. Remember one thing that whenever calculating the instantaneous value of voltage or instantaneous value of current, whatever the instantaneous values in terms of Vm sin omega t or is Im sin omega t, you should keep your calculator in radian mode because omega is there. Omega is nothing but radian per second, so that you have to keep your calculator in radian mode, then you have to calculate the value of voltage. If you're calculating the same if you're calculating the same value of voltage for the degree mode means you'll get different answer, so that you have to keep your calculator in radian mode. Clear? Similarly now 2a RMS value. So what they ask, define RMS value of an alternating current. Show that this current is proportional to maximum value. That is IRMS is directly proportional to IM. So most of the students, what you guys will do that it's just like everybody will do like this. So what you guys can do is that you're not able to write the definitions. So they are given RMS value of an alternating current. So you will be getting more excited. You skip that definition. You directly started to write from the derivation. So remember that if they asked it for 8 marks, means definition is having 2 to 3 marks. So that should not ignore the definition of RMS value. So what is the definition of RMS value or else effective value or else root mean square value is that suppose when the steady current flowing through the given resistor for a given time that will be produces the same amount of heat as produced by the alternating current when flowing through the same resistance for the same time. So in normal language to understand RMS value, there is a resistor. For example, there will be 1 kilo ohm resistor. For that 1 kilo ohm resistor, if you're giving DC supply, the resistor started to heating up. So it will be start to heat up for some time. Okay. So if you're considering the same 1 kilo ohm resistor, if you're giving the AC supply to the same resistor, the time taken for the heating up will be same for the DC as well as AC for the resistor. So that will be the RMS value definition. And if you're deriving the expression without waveform, you'll get 0 marks again. So that first remember the input waveform, that is a pure sinusoidal waveform. Then we define RMS root means square. Square it says so that 0 to pi half cycle, it is a positive. So positive square is nothing but plus into plus, so you'll get plus only. So that amplitude is more than input voltage square. Similarly, you can observe second half cycle, negative, negative, minus into minus, you'll get plus again. So that again it is positive half cycle, which means that the waveform from 0 to pi is the same as waveform from pi to 2 pi. So that instance you can consider either half cycle or full cycle. If you are considering the full cycle 0 to 2 pi, if you are considering half cycle 0 to pi, that difference you can see in different textbooks. Okay, so now I'll define the RMS value, that is the ratio of area under curve for half cycle to the length of base over half cycle, either full cycle also. So area under curve for half cycle means 0 to pi. See, I'm considering a small area. So it is having, what is the waveform? You will be having the root mean square, that's nothing but I square with respect to d theta from 0 to pi. So that I am right here, integration from 0 to pi I square d theta, that is the area under curve for half cycle. Next, length of base over half cycle. Length means what? 0 to pi. Maximum value minus or is final value minus initial value. Pi minus 0, you'll get pi only. So this is how we have to remember. Once after that, what is I? Instantaneous value of current. Instantaneous value of current I is given by Im sin theta. Then you substitute the value of Im sin theta into this equation. Then simplify, get the value of IRMS. Remember, you are defining IRMS square. At the end, you have to get what? Square root. If you're not writing the square root, you just write it as Im square by 2. So I have tried Im by root 2 is the final answer. So I have tried that. So that you can see now instantaneous is given by Im sin theta. For the equation 1 by pi, that is the area under curve for half cycle is 0 to pi I square d theta divided by base is pi. So I am rewriting that as 1 by pi into integration from 0 to pi I square d theta. What is I? I am sine theta. What is I square? I am square sine square theta. And I'm taking I am square outside. You will get I am square by pi. Sine square you can write it in a other way. That is 1 minus cos 2 theta by 2. Then you can do integration. In simplification, you will get the value of RMS current as Im by root 2. So this integration and all the basics of maths, I hope you guys know about the integration. Don't need to explain much here because we are just solving what model question papers. Okay. So now here, one thing you should, the alternative questions what you can expect apart from this. So here they asked RMS current is directly proportional to maximum value. Similarly, they can ask RMS value of voltage is directly proportional to maximum voltage. Or else you should remember one thing that in this case you have to observe questions properly that either they ask alternating voltage or alternating current or alternating quantity. If they use word called alternating voltage, see now here define RMS value of an alternating current they ask. Suppose if it is the RMS value of alternating voltage, that is nothing but VRMS. If it is alternating quantity, it's nothing but either it is a VRMS or else IRMS that you have to remember. Clear? Similarly, now back to the question number 2B. So 2B, what it is having a simple problem. Just look into here a circuit consisting of 12 ohm, 18 ohm, 36 ohm respectively joined in parallel. Means there are three resistors called 12 ohm, 18 ohm, 36 ohm. They are connected in parallel and this combination is connected in series with a fourth resistance. Remember they were not given the value of fourth resistor. That is nothing but R. And the whole circuit is supplied by 60 volts and it is found that the power dissipated in 12 ohm resistance is 36 watt. They are given the hint now. What is the hint? There will be power dissipation in 12 ohm, that will be 36 watt. What you have to find? The value of fourth resistance, nothing but unknown resistor R, and total power dissipated in a group, that is nothing but P you have to find. So now you can see they are not given the circuit diagram, you only have to draw the circuit. It is having 12 ohm, 18 ohm. Circuit consists of 12 ohm, 18 ohm, 36 ohm connected in parallel. And this combination is connected in series with a R. And the supply voltage is 60. Total current is I. It is divided as I1, I2, I3. The same current is coming back. The I only coming back. So now, hint is power dissipated in 12 ohm. They are given 36 watt. Friends, before solving this problem, first let you guys know the method. What they asked are. So there are various ways to find the resistor R. First way, total current find muddy. Then you have to find the value of total R equivalent. V equals to I into R equivalent. So you'll get the value of R equivalent. Then reduce, you'll get the R equivalent. So that will be complicated. So just use what simple methods instead of doing the complications. What is a simple method? Total voltage is 60 volts. Okay. So first you find voltage across this branch, parallel branch. Say it as a VP I will write. V parallel branch. Okay. Total voltage is 60. Once after getting this, you will get the value of this voltage across R. Once after getting the voltage across R, if you know the value of total current, then you will get the value of resistor R. Very simple. Hint is that power dissipated in 12. So next what I will do, I hope you are getting now. I'm finding the voltage across 12 ohm. That will be same for 18 ohm and that will be same for 36 ohm. So that you can see V12 is same as V18 is same as V36. Why? Because it is a parallel combination. So that P12 is given by, we know that P you can write in three formula. One is V into I square R, or else V square by R. I am using the formula V12 square by R12 because they are given 12. So I'll get the value of V12, which is same as V18 and V36 because of parallel. So once after getting the value of V12, that is 20.784 volts, I'll calculate I1 is given by V12 by 12, that is same. Similarly, I2 is given by V18, that is nothing but 20.784 by 18. Similarly, you can get the value of I3, then you'll get the value of total current I. So now what is total voltage? 60. What is total current? 3.46. Directly you'll get the power now. Power dissipated in the group. Total power is given by V into I. That is nothing but 207.78. Next is to find the value of R. As I told, remember, total voltage we got, that is total voltage we know that 60 volts. Voltage across branch we are calculated, that is 20.784. What will be the voltage across R? V is given by VP plus VR. VR is given by V minus VP. So that you can see total voltage V is given by parallel combination, that is nothing but VP or else V12 ohm plus voltage across resistor VR. So that VR is given by, can see VR is given by V minus V12. What is V60? What is V12? 20 minus. You can get voltage across resistor 39.216 volts. Then you can find, just apply what? Ohm's law. V equals to I into R. That is nothing but VR equals to I into R. R value we have to find. I we know that is 3.463. Substitute that will get 11.32. This is the solution. Very simple way to understand. If you're having any doubts regarding this problem, you can drop a comment in comment box. I'll reply as early. Next is a last question to see. So further questions we'll discuss in part 2. So what is the 2C now? Justify why pure inductor does not consume any power when connected across single phase AC supply. So you have to do a derivation. Why pure inductor does not consume? Because you have to derive that total power is zero in a inductor. So first you will just have to write what simple circuit which consists of inductor across supply voltage V is given by Vm sin omega t. Once the supply is given to the inductor, the current starts to flow through the inductor, hence the flux is produced in the inductor, so that EMF is induced in the inductor, and the direction of induced EMF is always opposes the direction of applied voltage according to Lenz's law. So that V equals to minus E, I will write it directly, and we'll do some derivations that you already know for AC through pure inductor minus L according to Faraday's law. I want to write I, so that Vm sin omega t is nothing but instantaneous value of voltage. Then with the help of this, I will write Di equals to, see now I want Di, so Di equals to what? I'll send L to the left side. It becomes 1 by L, so that Vm by L sin omega t into dt. So I want only I. So what I will do? I will integrate on both sides. So once after simplifying this, you'll get current, that is Im sin omega t minus pi by 2. Then you have to do the power. So instantaneous value of power is given by P equals to. So I am not explaining this simplification, as you already know. If you want me, I'll just tell you once. See, substituting here, I equals to Vm by L minus cos omega t by omega. Integration of sin omega t is minus cos omega t by omega. So I want to write this expression in terms of sin omega t. Why? Because the instantaneous value of current is given by standard current is given by Im sin omega t. Im sin omega t. But here there is a cos omega t. I want to write in terms of sin omega t, so that I will convert that cos to sin with the help of trigonometry rules. That is, I will write sin omega t. That is a cos omega t. I will write in terms of sin, that is sin pi by 2 minus omega t. But we have what? minus cos omega t, so that we can get that omega t minus pi by 2. Then this is the equation. Then power, you have to write Vi, instantaneous value of voltage and current, whereas V is Vm sin omega t. So I just now we are getting that is Im sin omega t minus pi by 2 for inductance. Similarly, Im sin omega t plus pi by 2 for capacitance. So again simplifying, minus Vm Im sin omega t. Sin omega t minus pi by 2 I am writing in terms of cos, again we can get minus cos omega t as per the previous explanation. So that you can see here also I was written sin omega t minus pi by 2, you can write it as a minus cos omega t. So you can get here sin omega t into cos omega t, you can write in terms of sin 2 omega t by 2. So here you can observe the power curve is a sine curve of frequency that will be having the double the frequency of rated voltage. So that you can consider this power as 0. Once after that, you have to draw the what? Waveform of voltage. You can observe waveform of voltage, pure sinusoidal. Current lags the voltage, so that current waveform. Then for each instant, you have to write the power. So you can see here for first instant, voltage is positive, current is negative. So that power is also plus into minus, plus p into minus I, you get negative only. Again from instant from here to pi, the voltage waveform is positive, current waveform is positive, plus into plus you will get plus only, so that power is positive. So this is the waveform. I hope you are understanding the videos and explanation regarding module 1. So I will do part 2 for next section. So that will be containing module 2, module 3, and again part 3 that will be containing module 4 and 5. So thank you for watching this video. So I hope you are getting some knowledge with the help of this video. Subscribe, and also I hope if you are having any doubts, you can paste it in a comment box. Thank you one and all. Have a nice day.